All right, guys, I'm going to give you a brief overview of something we call the Stinky Feet lab for obvious reasons. So if you were here doing this lab, you would use your own shoe. But I'm just going to run through what the process is so that you can get an idea of what you were meant to see. So you start off with your shoe. You would weigh your shoe and record that reading, which I will provide you the data for in a little bit. And then you would put your shoe here. You would take a spring scale and you would hook it up to your shoe, and then you would pull your shoe. I'm going to turn it this way. You would pull your shoe horizontally at a constant velocity. And you should recall that constant velocity is code word, which means that the sum of the forces acting on the shoe would be equal. So we know we have the weight of my shoe, which we just recorded. We have the normal force, which is the force pushing up on the shoe. When I pull the shoe to the right at a force, that pulling force is going to the right here, and then there is a force that is opposing it, and that's the force that is the point of this lab, which is friction. So when I pull here, if I look at my force probe, I can record what the friction force is. So really I'm measuring with a force that I'm pulling with, but because this is going to be in dynamic equilibrium, because I'm pulling at a constant force, I will have measured the friction force, okay? So as I go through, and I'm just gonna kind of show you, you'll be able to see on here kind of how it changes. So you can see it's pretty constant right here, and I'm at about, as I go there, 2.5, maybe 3 newtons. So I'm not going to really tell you the numbers too much because I want to give you some fake data that I already have. So then that was for just the shoe on this surface. So then I would take a weight that I would, again, weigh this, then put it in my shoe, and then I would do that again. And you'll see that now I have to pull it with a much larger force, okay, to get it going at a constant rate. So by putting this weight in the shoe, I have to now apply a greater force to get it moving at a constant velocity, okay? Then I would take 2 weights. I would weigh both of them, put them in my shoe, and I would do this all over again, and you'll see that it takes an even greater force to pull horizontally. And then I would do it one more time with a really large weight, and now when I go to do this, it takes a really large force to get it moving. Now I'm up to, looked like about 14 newtons right there. So I'm going to give you some fake data on this. That is actually real data, but from another time when I did this. So normally when we do the Stinky Feet lab, we would do it on this surface. Everybody would do it on their own desk. And then I would set you loose and say, find 2 other surfaces to do this on. And you can probably imagine that if you were to do this on different surfaces, you would get different numbers, okay? The weights would be the same, but what would be different is the force that I have to pull with. So if I did this on ice, it'd be much easier to pull this along. Okay, if I were to do this on, say, like a carpet, it would be more difficult to pull it on. So you would have tried 2 other surfaces and seen what the data gives you. And I'm going to show you data for 2 other surfaces, including the surface that I just did right here.